Welcome to our channel. So continuing with our series on advanced steel, we have already seen how we can use some of its tools for the automatic and quick distribution of detailed connections throughout our model. Here, for example, we have a group of anchor connections that we have placed with the help of the tools found in the joint utilities area, meaning that, and regardless of their level of detail, it wasn't necessary for us to place each of these connections one by one. However, and although this does save us a lot of time, one of the issues that we may still find is that when it comes to performing any modification to their design, this needs to be repeated for each corresponding element in the model. To illustrate this more clearly, let's, for example, adjust the dimensions of the plate for one of these connections. Now, and while this change was made relatively quickly, we would still need to carry out these same modifications for each of these connections if we are to keep the model consistent. So instead, what we can do is create what's known in advanced steel as a joint group, which essentially creates a relationship between a given set of similar connections so they always stay updated together as a single group. For this purpose, let's pull up the Advanced Steel tool palette and look for the corresponding tool, or the one that will allow us to create the aforementioned group. In this case, let's simply choose the Add Joint to a Joint Group tool, followed by the first connection that will be added to the group, or the joint that will be linked to the source connection. That in this case could simply be the connection corresponding to this first column, or any other connection of our choosing. And with this thus defined, let's repeat this process for the remaining connections in the model. For this example, let's limit ourselves to the ones on the first row of columns. This would be then our first joint group. So for example, and now that we have placed all these connections inside the same group, let's take this opportunity to verify its design. Specifically, let's check if this current design is capable of bearing the internal forces at the node. And in case you are wondering, this information can either be provided by the structural engineer or directly obtained from structural analysis software such as Autodesk Robot Structural Analysis Professional. And it is many times a necessary step to verify if our design is actually safe and structurally sound. Or, in other words, to simply ensure that our structure won't fall apart due to faulty connection design. In this case, for example, we can see that we are getting a set of warnings since this connection, as currently configured, isn't compliant with the selected design code, meaning that it is also not capable of properly dealing with the resulting internal forces at the joint. So let's go ahead and perform all the necessary adjustments so our design is actually safe and compliant with the code. As we can see, and as soon as any modification is performed on this connection, this will be shared among all other instances in the group. Now, and as for how to know which changes need to be made to the design of the connection, this entirely depends on its particular failure mechanisms, but in case you are interested, Autodesk Robot can also provide us with the specific design requirements that the connection needs to be both safe and compliant with the code. So, and with these adjustments now completed, let's go ahead and check if our design is correct from a structural analysis point of view. As you can see, and thanks to the joint group feature, we have obtained a structural model that's not just consistent, but also compliant and safe. At Virginia-e-Learning, this is exactly the type of workflow we focus on teaching, helping you move beyond manual drafting and toward professional, production-ready structural steel detailing using advanced steel. If you'd like to learn more, be sure to visit our website, where you'll find multiple advanced steel courses designed around real industrial projects and practical use cases. And don't forget to subscribe to the channel for more videos in this series, where we explore tools, workflows, and best practices for structural steel modeling and detailing in advanced steel.